Okay, happy Thursday. How's everyone doing? You feeling good about the mini exam? Okay, that's nice. My goal is always that you feel as prepared as you want to feel prepared. So if you ever need anything extra, if you didn't feel like you were prepared enough for the last one and you want more material for the next one, just let me know. I'm always here for that. My job is just to make sure that you have all the resources to be as prepared as you want to be. So Top Hat, we're live today. Today we're trying to get through the end of data cleaning, so part 2.1, and then hopefully we make our way all the way through data transformations, which is 2.2. I'm postponing the due date for the homework. So homework, homework 2.1 is due on Friday, but then homework 2.2 isn't due until next week. So no rush on that. You've just been given another little treat. Go celebrate or something. Anyone gonna be outside this weekend? Nice. I'm taking my child camping for the first time. We got a giant tent. We're going to drive a car into a campsite, and the tent is big enough to take a bassinet. So we'll see how this goes. That's what we're doing on Saturday night. We have some friends turning 4 years old, so that's fun. So we have a big one for today. Hopefully we get through everything. There's a good chance we won't, and if we don't, then we'll just pick it up on Tuesday. So that's part of why the due date is pushed back, just so we don't feel any rush to push it. I wanted to show you the cutest thing you'll see all day, if anyone's interested. This was yesterday. Maxine was hanging out with some friends of ours next door, and they captured this. You can't tell me that's not cute. Also, this was from a couple days ago. It started raining and we went for a walk. This is, she just spontaneously started laughing and got the rest of us laughing. So you're not here for baby content, you're here for data analysis. Unfortunately, maybe. So where we're going for today, we're going to pick up where we left off last time with data cleaning. And then we're going to start talking about doing more fundamental transformations of data. So I'm going to show you an example very similar to what we've seen before, where we have a problem with prices. We'll talk about making comparisons with prices, and then we'll talk about some ways we can improve our data using what we call data transformations. So that's where we're going. Are there any questions, any housekeeping things before we get going? Well, great. That'll probably be the cutest thing you see all day. So last time we talked about data cleaning, you'll remember this is data from our survey. So we had, ages listed in birthdays, and we said, that's not very helpful. If we're trying to understand the relationship between ages and distance from school, this is not the right format to look at. We just really can't, every once in a while you'll see a birthday with two people born on the same day, but that's pretty unusual. So what we do instead is we try to collect data. We can take our variable that looks like this and turn it not just into a number, but into a year. So we can take this thing and just extract off the last bit. And we're going to walk through how to do this. We did a bit of this, I think, in Excel. And did we do this in Python? I have two classes, and we did it slightly differently in both. Did we do it in Python? I don't think we did. So let's do it in Python. And then the reason we do this is because we want to calculate I guess we calculated the average, the median year. But then we also looked at data that comes in sort of less systematic formats, like with distance from school. I just left in the survey, I left a sort of a text entry. So you just answered in whatever way you wanted to. And so we got a lot of different types of responses. Interesting enough, we had a couple people saying they were 25 miles from school. But the point here is we had lots of different formats, and this is not very conducive to making like a histogram, summarizing a numerical variable, which is what this appropriately should be. And so what we did is we tried to convert these things into something that we could actually handle with a computer. My attempt at this looks like this. We have, the distribution. We've talked about this a couple of times, but these have to all be numbers for us to deal with a histogram in this way, right? So to make ordinal comparisons on the horizontal axis to sort of order the distances, we have to turn them into numbers. And so that's what we did, or that's what we will do. That's what I did for this figure. We need very far to be turned into something, and as I'll show you, we'll turn that into an NA or an NaN, just representing null values. And then entries like 500 will just become a number. So this is a text entry, and this is a number. And so we'll make those comparisons. And I mentioned we've already walked through this table, but you can see the old value, and we just want it to be like a true number. These are all, they look like numbers. A computer can easily turn them into numbers. And so when we turn it into numbers, we just get a real number. But when we try to ask a computer to turn these things into numbers, it complains, and it'll just spit out an NaN, which is essentially just telling us that the computer can't do it. It doesn't know how to turn this into a number. So we need some way to deal with missing values. We walked through some of the options for dealing with missing values. The first one, the most labor intensive, is just going through one by one and just converting this thing into a number. So we just, we use our brains, and we just convert this into 176. It looks like 176 to us. A computer isn't smart enough to be able to do that. And so we just do it manually. Someone in my other class mentioned the possibility of using AI to do these things, and that's a recent possibility. In fact, Microsoft is building an AI into Excel. I think it just dropped like last week. You have to pay for it, but that's something that's becoming available. So one approach to dealing with these things, which I actually took, is just to go one by one and convert these things into numbers. And this is reasonable for a population this small. So within my two classes, this is something feasible. So I can just go through and just do all the conversions. But if you're dealing with very large data sets, this is not feasible. So we have to do something in that case. And if we're going to not handle these conversions by hand, there are really two options. One is to drop, just to eliminate all of the data points that have NA. I'm going to show you how to do this. It's pretty straightforward. This is the main approach. This is what I recommend everyone take. This is the least problematic. You just drop all of the data points that don't have a reasonable value. It reduces the sample size, but it's really simple, and it's straightforward. It's easy to justify. The second one is a little harder to justify, and that's to take some other number and enter it in place of the NA. So you could answer 0. So if you don't have a comprehensible answer for your distances, we can just enter 0 instead, which introduces the possibility of bias. So I don't recommend you take this approach. I mention it because it is sometimes the right approach, but I think in general, it's very often a source of bias. So I don't recommend taking this approach. Generally, stay away from this. Okay. So in this case, I think the right approach is to drop if we don't want to go through one by one and do the replacing. And like I told you last time, I had a question that I was interested in. I'm presenting that question to you. The answer to that question is basically there is no relationship here, or at least I can't tell if there is one. We're in part 3 and 4, we're going to start introducing the ways that we test whether there is a relationship between two variables. But just doing this by eye, I don't see anything here, which is often going to be the case with your research. So your first attempt at your final project may end up with nothing. And that's, so many of my students in past semesters present null results, and that's very okay. In fact, we need to be encouraging null results as appropriate and as acceptable. If we push people to only present positive or negative results, we end up creating real problems in our literature, which is currently the case, actually. So presenting null results, I think, is we should be strongly encouraging. But it's sort of more fun to present something there. So often I've seen students find a null result and then also do something extra, which is very okay. Okay, not much of a relationship, so it doesn't really matter how far away your hometown is from Pittsburgh. Everyone is about the same age. That's cool. Okay, so some common data cleaning operations we have. There's string parsing, so taking strings and turning them into numbers, or just generally extracting information from text. We have type conversions, so turning text into numbers. And then we also have this way of thinking about missing values. We can either drop or replace them. Okay, so this is about where we left off last time. We did some of this in Excel. So we turned dates into years in Excel. And then what we're going to do is something similar in Python, just extracting dates and then turning them into years. Like I promised last time, this is the very bottom of the sort of interesting like scale for this semester. Once we get through this, we'll talk about something more valuable I don't want to say more valuable. It's more interesting for economists. We're going to talk about prices and some data transformations around prices, which will feel in a lot of ways very similar to data cleaning. The reason we must talk about data cleaning is so far I've given you very nice data sets that you can just open up and work with. But you would not be complete economic data analysts if you didn't know at least a little bit about what it looks like to work with unclean data that we have to transform. So that's what we're doing here. So the first thing we did last time, we opened we were in our part 2.1, and we were working with the fall survey data, and this was the raw format. And so what we did was we went through and tried to construct the birth year. And what we saw last time was, and I was actually a little clumsy with this. This is a date column, so you can look up here and look at the column type. Excel looked at this and saw that it was a date, and so it just extracted it as a date. It just told us that this was actually a date. So all we had to do actually to get the birth year was just apply the function year, which converted the date in C2 into just the year. So it took off everything else and just gave us a number that represented the year. So we could just go through and calculate the median year. So that was here. So median year. Any questions about this? You all feel comfortable with this so far? Who's hyped to talk about data cleaning today? Okay, that's more enthusiasm than I was expecting, which frankly is excellent, especially after a mini exam. Okay, yeah, I give you a mini exam and then I talk to you about the least interesting thing. Quite the burden for you to carry. Okay, so this is what we did last time. We're going to do something similar in Python. So if you go to the course website, you just scroll over to the notebook, click on the notebook as always. I think we opened this last time. Did we do this? Or am I just ahead with my other class? Sometimes I lose track. Did we do this? Okay, so we did birth year. Okay, nice. Yep, so what we did here, just to remind ourselves, including me apparently, of, thank you, self-deprecating humor, so we loaded the survey data. Every time you open the notebook, you're gonna have to do this again. We said, after we've loaded it, what if we just want one column? All we have to do is use this bracket notation. This is just telling Python to just look at the one column. So when we just run this one column, you can see we get all of the index values, which are the timestamps, and then we get the birthdays. But what we're wanting is not the birthdays, it's the birth years. So Python sees this as a text value, what we call a string. And we've talked about strings before, like I could just put my name in here. So, and then if I print out name, then it just prints out this thing. This is a string, if you'll remember. And we can call it whatever we want. That's what is listed here. Python sees this as strings. So the first thing we have to do is convert this into a date. And one way of doing that, there are multiple, but the one we're going to use today is to apply this pandas toDateTime operation. So we're just putting this column, just the whole column, directly into the function, and then creating a new column based on that old one. So I'm going to create a new column called birthday, which is just the datetime version of our datetime column, of our when is your birthday column. So when I run this, I now have another column. So you can see there's no datetime column yet, but if I rerun this, you can see that I've created a new column called birthday. Any questions here? How many of you were able to get this? If you weren't, there's code in the slides to be able to do this, so you can just hop over here. Any questions about what we've done? This is the thing that Excel did for you automatically, which in some ways is kind of nice. When you loaded the data set, the survey data, it automatically detected that this was a date column, and it just converted it into a date column. So you can see that these dates are automatically listed as a date. So the next thing we're going to do is actually we're going to extract year from the date. So because we have a date column, all we have to do is call a function on it to get the year. So we don't have to do anything fancy, just ask it for a year. And we can do this to the entire column. So all we have to do is get this DT module and then get year. So I'm just going to apply this thing. So this is just getting year from the date column. And if I now show the whole data set again, I not only have birthday, but I have birth year. So you can see these are dates, but this is just the year. We can do the same thing for other other kinds of values we might care about. And we can create new columns for each one. So maybe we say birth month, and all I have to do is pull out the month from the birthday. If I do this, we can now see I have birth month. And this is listed in the number for the month, but I could also do this for, I think there's birth month name, which will then give, nope, that's not what I want. So you have to kind of play around with these things. I never really remember. You can ask ChatGPT to do this stuff if you don't remember. But you can get any kind of thing you want just using some combination of operations like this. If this feels a little overwhelming, don't worry so much about this. I'm showing you this kind of operation to tell you what kind of thing you can do, not that you need to remember each one of these steps. The main things, we can convert an old variable into a new one, and then we can extract text from time. Okay, how many of you were able to get the year? Okay, so then last time we got the mode. So this is just a statistical measure giving us the most common year. We can also do median, which gives us this thing. And turns out in this case, median and mode are both the same. Okay, and then if you wanted to, you could make a nice figure, sns.histplot survey x, say birth year, and that could look like this. Okay. Any questions here? So this is dealing with dates. We can also deal with numbers. So you'll remember in with our numbers, we had this variable approximately how many miles away from Pittsburgh is your hometown. So what we're going to do next is actually try to turn that column into a numeric value. And we're going to look at some places where Python makes a mistake or isn't sophisticated enough to sort of read text and turn it into a number. All we're doing here is asking pandas to convert this old column into numbers. The cases where it can't convert to numbers, we're going to say this is just telling Python to try, and if it can't convert the value to a number, then just to enter a blank value. That's what this errors code is for. So I'm just going to copy this over. So we'll say handling numbers. So I'm just going to enter this. We're going to construct a distance column. I might make this capital. You can do what you like. So all we're going to do is construct a new column. That's what we're doing here, defining a new column, which is taking as input the survey with the distance values, and then just constructing a numerical column from that. So let's just look at this. So survey distance, and then we'll run this out. And actually, let's put the old and the new ones right next to each other. So I'm just gonna, you don't have to do this directly if you don't want to. I'm just gonna list out both the old and the new columns next to each other. And the way we do this is just by entering both the old column name and the new column name as a list. So I'm gonna say distance. So I have the new column name in this double bracket, and then I have the old column name in this double bracket. And what this lets me do is see both the old and the new column next to each other. And this makes it easier to do this comparison. So you can see most of the time your classmates entered something that looks like a mile, which is nice. But not everyone did. So some people not incorrectly listed units. Listing units is nice. In this case, Python doesn't know what to do with units. So Python treats this 305 miles as NaN. Anyone live 305 miles from Pittsburgh? Nice. So this is great units. I love entering units, but Python doesn't know what to do with it. Python is just going to treat this as a null value. Okay. Question for you. What would you do in this case? Yeah, Darren.
I would, well, just in general, I would apply it to the whole problem, but I would use the split function that allows you to split the things that are by a certain parameter. So in this case, the parameter uses a space, and then get the one that isn't.
Nice. So Darren knows a little bit about handling strings in Python and knows that we can actually split strings based on text values. So one thing we can see here, maybe we see a lot of people entering correctly units. And what we might want to do is just take off all of the units from the back. And we can do this using a split function. It's a little bit more sophisticated than I need you to know. But I have some text, some code in the slides that shows some of this. What else might you do? Any other ideas here? What if we just drop these values? I think this would be a sort of unsophisticated way of going, but a pretty good first approach. So if we were to just plot a histogram of distances, so we go SNS dot histplot, survey distance, and then we just set up the range. Maybe we'll go up to 10,000, and then bins of 100. Let's do 50. If we do this, anyone see what I did wrong here? For some reason, the index was having some issues. Did you all get that same error? Okay. I'm not sure why it's giving us a problem here. If you put a reset index, that should fix the problem. But I'm not really sure what happened here. But something in the process of, this is the second time, 2 classes in a row where my test in my office and the in-class live demo didn't match. So it's you all saw the Meta Ray-Bans classes, the live demos, both of them failed. Live demos have that option. But this is, we've dropped, so in our data we have NaN showing up. Python is just going to drop all those values and try to plot this, but with the dropped values. Any questions here? Yeah.
Scroll to the line of code before I want to see whether that fixes the error.
This line shouldn't fix the error. But we're going to talk about dropping empty values, which may fix the error.
Okay.
Okay. So maybe I've made that more complicated than it needs to be. All right, so this is one way of handling empty values. The other could be to just go to Excel and look at the values themselves and try to convert these. I think this is maybe one case where Excel is actually slightly easier than Python when we're dealing with exceptions. So what we're going to do is try to perform the exact same operations with Excel. So I'm going to right-click here and then insert a new column. I'm going to call this distance. And if you want to, you can space this out. So you can see that Excel sees this as just a general format. It doesn't see it as a specific format. But you can see that for the text strings, it puts the values on one side, and for the numeric strings, it puts them on the other. Anyone know how we might try to convert this column into a numerical column? Anyone know the function? Let's try numeric. Nope. So again, the data cleaning is the messiest thing we do. Maybe number value? So this isn't the same function I had in my office, but this looks like it's working. Let's try the first couple. Yeah, so this is giving us this is behaving correctly. So what I did is I used number value. Just like in Python, I always have to look up what the function is. So Google or an AI is very helpful in this case. You're not going to remember each one of these functions for all of the things you try to do. So you can see me flailing around on a computer. This is part of the process. So all I'm going to do is try to convert 400 into a number. And so I just select that and then drag it down. But you can see Excel has the same problem that Python does when it sees like the units on the end. So 176 miles away. It doesn't know what to do in that case, and so it prints an empty value here. So it's saying that it's an error. So we can just drag this all the way down. I'm going to show you a systematic way of dealing with these errors. A sort of a simple systematic way of dealing with these errors. There's the Python approach, which is just to drop the empty values. But in this case, what if we actually want to be a little bit more systematic? What we can do, I would never recommend clicking on this and then just editing the direct survey result. Anyone know what we should do instead? Don't edit what someone else has entered in the data set. Anyone know what we should do? There are probably two ways of doing this. One, you could either just try to rewrite over the function. So instead of editing the direct entry of 176 miles, we could, and then we try to make the adjustment using a function. We can edit directly over the entry, the function result, which is the error. So I could say 176 miles here, or we could create a second column where we say, we could call this distance clean. And we could say, we could just copy over all of the results here, and then edit this value. So we'd say 176. So this is not a function. This is just us updating the value itself while keeping track of what was response and what's been processed. This is a responsible way of dealing with survey results. I really don't want to see anyone editing the direct survey. This is difficult to keep track of, and for reproducible science, we really don't see this as responsible. So keep this, and then in some way keep track of what you're entering, and what's sort of a function telling, sort of updating the values. So then we could just go through, if we like. So call this 0. Maybe we call this 425, the average of 400 and 450. And then we could just go one by one systematically through and update these values. Any questions about this? How many of you want to go through each of these values? Me neither. So thankfully, I've done something extra, and in the slides, I'm going to show you how to do this kind of conversion in 2 different ways. So the first one, we're just going to drop all of the empty values in Python, and then I'm going to give you some code to just systematically update all of the survey responses so we can do something nice in class without having to actually update these things. Okay, so the first thing, I think the error here might have been due to the bunch of NAs. So let's just go through and count how many NAs there are. Handle missing values. So the first thing, let's just check how many NAs there are in the data set. So this is just checking, is it an NA? So if we just list out the column here, we should see at this point that this is an NA. So I'm just going to say dot is NA, and this is just going to give us a list of true and false values. For this one specifically, we see that because it was an NA, this new column is true. Everything else is false. So if it's not an NA, then it returns false. If it is NA, then it returns true. And then all we have to do is just count them up. Count up how many true values there are. And we can see that there are 22 missing values due to the formatting issue. Y'all love to talk about formatting issues. How many of you love APA, like citation format? Chicago? What's your favorite one? MLA? Okay. APA. I always used APA when I had to. Now we can do this with code. So I haven't done that in years. But I liked APA. MLA was also good. So nice. So this is just counting up all of the NAs. But we want a new data set that, that doesn't have errors. What we can do is just drop missing values. So we're going to create a data set of all of the non error rows. So this is a little bit sophisticated. This subset inside the drop NA function, in our case, you don't actually need this. But here's the code to do it. This is the more precise way of doing it. So if we want a new data set that doesn't have the NAs, we can just run this, and that will drop all the 22 values. Oh, this should just say distance. You can also run this without the subset. This will just drop all of the NAs in the data set. Any questions here? This is something you'll do in your homework. I give you some hints in the homework as you go through. So I don't want you feeling like this is a daunting task. These are just some of the kinds of things we have to do when we're dealing with raw data. And each situation is slightly different. So in this case, I think sns.histplot survey dropped x is equal to distance. I think, should this work? Yeah. Okay, so I think that error above was just because there were NAs in our data set. Okay, now the last thing we're going to do is, so in the slides I actually have, this is just how you replace NAs with something else, but this is the bad approach. I don't recommend you take this. This is just how you would do it. We're going to skip it for today. But I've actually gone through and written out all of the replacements. So you'll remember in Excel, what we would do is just take this thing and turn it into a 176. I've just created a dictionary that will translate one into the other. This took me a second, and I put all the code in the slides for you to do it if you wish. Where we take this thing and turn it into this, we take this thing and we turn it into this. And I've just listed these out. And I say, live in Pittsburgh. Okay, that means you're 0 miles away from Pittsburgh. So I've just listed all these things out in what we call a dictionary. You don't need to know too much about dictionaries. We're not really going to use them that often, but this is what it looks like. And then we have this little bit at the end, which is just replacing the old value with the new value in the dictionary. So if we copy this over, and one more error for today. This should say survey instead of data. There is no dataset data. And then I made this capital. So just make sure your variables are all nice. And then maybe we'll call this clean. So I'm just creating a new cleaned version. This first row just replaces the old ones that aren't numerical with ones that are numerical using this dictionary. So I'm just replacing everything using this replacements dictionary. And then I'm just turning everything into a number. And you can see, so we have distance, which is our old one, and some of them have NAs. Oh my goodness, another, not sure what that is. This is what data cleaning looks like. This is why I'm promising that this is the least interesting part of working with data. This is a thing we have to do, and there's no simple way of doing this thing. You're going to have to sort of struggle through some of these things, hopefully not that much. But this is another example of where my code didn't quite do what I wanted it to. So I'm going to have to go back and check why this is not being converted into 300. Okay, so in theory this should convert, and I think if you were to go through systematically you'd see that there were fewer NAs, but this one is still showing NA. Okay. Any questions about this? So I guess we could count the number of NAs. Y'all want to talk about data transformations? Nope. Still 22. Okay, I made a mistake somewhere. So my big punchline is totally ruined. But this is the general process. You would do these replacements if you wanted to do it by hand. But when you're dealing with very large data sets, my recommendation is you just drop the NAs, which is what we did. Which is what we did here. So dropping the NAs. All right. So let's leave data cleaning on a very uninteresting punchline. When you're dealing with data sets, you often are going to be given nice data sets, like I've done this semester so far. But often you'll actually have to do some work to prep your data set to make it look the way you want. And there's sort of an infinite amount of things that you can do. These are just 3 different types of data cleaning steps that you'll encounter. Your homework will be a little more systematic. There's 3 questions, and you'll just do those 3 types of data cleaning approaches with your homework. One of them relates to what we're talking about in data transformations for the rest of class. How many of you are feeling like you want to move on? Okay, so I talk about data cleaning. The reason we talk about it is because we have to deal with it, but I don't want to linger too long on it. A lot of the data sets you're going to be getting from me are just going to be pretty nice. But when you're thinking about your final project, you will have to do some data operations, some of these data cleaning steps. So that's why we talk about it at the beginning here. All right. Strange this worked for me earlier and not in class. Okay, so what we're going to do next is talk about some data transformations, and this is where we go back to some I think more interesting kind of slides. So I'm going to ask you a series of questions, and you're going to tell me what you like about the slides and how to answer my questions based on the figures. Do you remember this figure? After I've put all of you to sleep and convinced none of you to use Python. You remember this figure? Do you remember what the trend looked like? We concluded that there was a conclusion here. Do you remember what it was? Someone convinced me that I haven't entirely lost you. Yeah, Jason.
Generally, coffee prices from 1974 to 2022 have generally increased.
Have what?
Generally like increased.
So yeah, so we can see we had prices just under $2 in 1975, and then yeah, maybe recently, like due to COVID, we might see that prices are a little bit higher today. Yeah. What else might we see? There are some other things to notice about this pattern. It also might look like they're relatively flat, like the number itself. There might be this slight uptick near the end because of COVID, but it's surprising to me how kind of flat they are. What else might we notice? Convince me I haven't totally lost you. So is the price of coffee in 1980 about as expensive as it is today? So in 1980, just picture this. You're going to the store. You see that the price, let's say this is $1.50. Yeah, $1.50. you go to the store in 1980 and you see that coffee is $1.50, is that the same, as like a percentage of your income? Is that the same as $1.50 today? Someone tell me why. Why are these not the same thing? Yeah, Alexis. Inflation. Anyone hear about inflation recently? Kind of a big deal. Prices in general change. This is what we call inflation or deflation, just the change in how much a dollar is worth today versus at a different time. And the price, the value of a dollar in 1980 is very different than it is today. So if you're looking at this figure and you're thinking about trends, and we're thinking about like the comparison of prices through time, how many of you like this figure? How many of you don't like this figure? And why don't we like this figure? Even though I showed it to you before. We don't like this figure because it doesn't accurately represent the cost of coffee through time. This is nominal prices when most of the time the thing we care about is effectively how expensive the thing was. Anyone know what we do? Darren?
You can adjust your GDP. So essentially wait for the nominal to be.
Yeah, we do this with GDP. The adjustment is with the Consumer Price Index, what we call the CPI, and we often do this with GDP for sure. So this is what a dollar in 1970 is worth at all of these years. And to me, what's amazing is if you had a dollar in 1970 was worth about the same as $8 today. Wild. So like a burger in 1970 being $1 is about the same as a burger today being $8. Like the dollar store, it's like an $8 store today. So the thing we need to do in this case is make this adjustment. And this is what the adjustment looks like. This is once we've adjusted for the changes in the price of the dollar, the changes in the value of the dollar through time. Okay, what do you notice about the trend now? Yeah, Ruby. Yeah, so the price of coffee has gone down by quite a bit, it seems. Yeah. Which is often the case with things like commodities. Prices seem to go down as we just move forward with our productions. If you're interested in these kinds of things, you can study international trade and production. Okay, so I think this is pretty interesting. I would say this figure, because these are in nominal values, this is pretty misleading about how the price of coffee has changed, where this figure is much more useful to us as we're trying to make comparisons about the costliness of coffee through time. It is much cheaper to buy coffee today than it was, at least in the 70s. It seems like it's been relatively flat since like 2000. So we're going to do this price adjustment. This is this kind of thing. This inflation adjusted dollars is a common thing we do as economists. So we're going to spend a few minutes just doing this in Excel and in Python. Okay. So anyone excited to do one more thing before we take off? I have notes so we don't get this one wrong. Okay, I'll post these notes later. So So we can hop over to part 2.2. And you can see the homework file has not been posted. I think I mentioned this at the beginning of class. You can turn this in on Friday next week, so no rush on that. So the first thing we're going to do is just look at coffee prices. So we'll just download this data set. And then what I'm going to do is create our 2.2 folder, part 2.2. And as always, have I told you this? I just had a child. Have I told you this? You should always create a folder for your projects, each one. I recommend you keep your files organized. So I created a part 2.2, and then I'm going to go to my downloads folder and drag over coffee prices CPI. So when I open this, I'm going to hit save as, and save it as an Excel workbook. And we'll just take a look at what we see here. Okay. How many of you have done a CPI conversion before? I'm not a macroeconomist. This doesn't come naturally to me. I had to look this up. I don't do price conversions very often. So I have notes to make sure we don't get lost. I did a couple of things beforehand. I collected CPI, the Consumer Price Index, which is a measure of the sort of value of a dollar. And then I made a conversion. So I did this for you. This is the value of a dollar today. And this is the price at this date. So we have a time series, which we've actually already worked with this data set in an earlier exercise. We created a line graph of prices through time. I think it was monthly, but in this case, we have daily prices, which is pretty amazing. But what we want is a real price. Instead of the nominal price, which we have listed, we want a real price. So what I'm going to do, actually, we're going to take a second here. I want you to try to figure this out before I tell you how to do it. We want a new column. We want, we're going to call this real price. And what we want is the price of coffee in this year adjusted for the price that it was, the value of the dollar at this time. So we're going to take like 2 or 3 minutes here. I want you to talk with your neighbor about how you might use these two numbers, this price and this value, to construct a real price just for this 1 year. And then we'll talk about how we go from there. You don't have to write any Excel yet if you don't want to. Feel free to write some Excel if you like. We're going to talk about how we do this. So we'll take maybe 2 or 3 minutes here. Think like a macroeconomist. It's difficult, but you can do it. Okay, someone know how to do this? Anyone want to take a guess? Yeah, love it.
Okay, so we decided we would do price divided by CPI times 100.
Okay, so
That's the formula.
correct.
How would we put it in Excel?
Okay, nice. So this is very good. So often we don't know how to write the functions with the software to do the thing that we want. The first step, as always, is to figure out what we're trying to do. And then we try to implement it with code or in Excel. So what Ruby's saying is we're going to take the nominal price, which is given to us here, and then we're going to divide this by the value of the dollar today. So this is essentially the value that a dollar today would be worth in a previous year. If you're a good macroeconomist, like I pretend to be for today, you could use CPI and then make the CPI conversion. But I've made your life easy just by giving you this thing. So let me show you how to do this in Excel. Anyone know how to divide two numbers in Excel? Yeah.
Do equals.
Okay.
Put the first number you want in.
Okay.
We'll just put a slash.
Okay.
So,
And then the second one. Any questions here? So let's hit enter, and we get this thing. And then all we have to do from here is just drag this all the way down. There's a faster way using copy paste if you know how to do that, but this is one way. Any questions here? It's a long data set. Any questions here? So then we can just select this column. If we want to make a figure, go to Insert. This is a time series, so we can just select this figure and then adjust the axis if we like. And this gives us the real price of coffee through these dates. If you're particularly proficient with Excel, you would understand if you hit Command or Control T, you can create a new table, and then you could insert a new table, a new column. But that's not the main point for today. Okay, any questions about this? All right, so that's how we do basic operations in Excel. That's what we call a data transformation, where we take existing data and we perform some mathematical operation on it. This is also very easy to do in in Python. So this, I think this might be the last thing we do for today. We can run over to the exercise 2.2, click on the notebook. Still haven't watched the notebook this semester. Every class I'm like, I should watch that movie tonight, and then I never do. So I've given you the file path for the coffee price data, and it looks like this. Anyone want to take a guess at how we would construct a real price in Python? We have our existing columns, but just like we did in Excel, we want a new column that represents the real price. Someone other than Darren. This is your opportunity to get this wrong. I've told you about lecture points I give out if you get things wrong. Someone want to make an attempt? How do we create a new column? Okay, instead of you answering to me in front of the entire class, I want you to answer to someone next to you. Make an attempt, and then I want you to report back to me. We'll take about 2 minutes here. I want you to create a new column of real prices in Python. You got it.
There we go. I would have guessed that.
See, I knew you would have.
Oh, yeah. It was totally me and not Gemini.
Oh, yeah. So, yeah, you could say create a column of real prices. Let's see. Price divided by today.
That's not what it's. I like that.
Okay, how many of you got it? How many of you did not get it? I'm looking for points. Okay, points. You got points. You got points. You got points. You got points. So someone want to walk me through how you thought about setting this up? Yeah, Ruby. No, this is good. Yeah.
Okay. Well, all honesty, I did use Gemini.
Okay.
But my thought process prior to that was kind of just doing like inputting the formula that I told you about.
Yeah.
In my class and that.
Yep.
So Gemini helped me with that code, which is CPI, and then square brackets real underscore price,
Okay.
and then
So let me just pause you for a second. What we're doing here, like we did with data cleaning, we're creating a new column. So in Excel, we did this operation by just going in and saying real price. So we're defining a new column that should be the construct based on something else in our data set. Okay? And what else?
hopefully this is right, but yeah, it's basically I don't know, it's separate, but
Yeah.
so it's going to be CPI square bracket price,
Okay.
and then divide by CPI square bracket CPI.
Okay. Or we're
Yeah.
we're going to use today.
Okay.
Yeah. So this is the value of a price today, of $1 today.
And then I guess Gemini helps that one because it uses CPI probably, but
Okay.
maybe we won't have to do Excel under it.
Yeah. So what we did in Excel was take one value and divide it by the other, and that gave us the real prices. In Excel, it's pretty easy. In Python, it is so easy. We're just going to take one column and divide it by the other. You'll remember, to call a particular column, all we do is look at the data set, CPI, and then we use these square brackets with the text inside of them to define one column. So all we're doing here is taking one column and dividing it by the other. And Python knows to go row by row and divide one value by the next. So we've created an entire new column, one row being divided by the other between these two columns, creating a new column, what we call real price. Okay, so if we run this, we can just verify our new data set has this new column, CPI. We have real price, and that looks like this. Okay, any questions? Okay, really nice. This is our first data transformation. This is a common one. I've set this up in a way that's pretty easy to do. There are more complicated versions of this, CPI conversions. If you get into macroeconomics, you'll do a lot more of this. But this is the basics. Next class, we're going to spend some time going back to Starbucks data. This is the example we're going to walk through next class. We have global Starbucks servers, and one question we might be interested in is how many Starbucks shops open up every hour throughout the day. And we're going to do this globally. So how many coffee shops are opening this hour? This is a question you might ask if you're running the Starbucks server globally. And it's not simple to answer. I mean, it's simple to answer with the data set, but we have to do an extra data transformation to be able to answer this question. So we're going to walk through this next time. We're going to look at this data set and do some more data transformations, and then hopefully get into part 2.3. Stick around if you have questions. Let me know if you have questions about the homework, which is due on Friday. And have a nice weekend. It's not going to rain.